All right, guys, we're down to our last two lectures. So 7.4 right now. So let's get going. Decimal percents and real numbers. So we're going to talk about percents. Fraction decimals and percents as representations of rational numbers with conversions from one to the other, proportional relationships to solve percent problems, techniques to solve problems including discounts, interest, compound interest, and percent increase, as well as percent decrease. Strategies for percent mental computation and estimation. Percents are special kinds of fractions. Namely, they're fractions where the denominator is 100. The word percent actually comes from the Latin phrase, which means percentum, which means per 100. So whenever we talk about percent, if we say 70%, we mean 70 out of 100. We say 30%, we mean 30 out of 100. So write each of the following as a percent. 0.03 is the same as 3%. 1.2 would be 120%. So remember, when it's in the hundreds place, you take this guide and put it over 100. So 3 over 100 is 3%. This would be 1 and 2/10. Well, if I wanted to make this to be over 100, if I multiplied by 10 over 10, that'd be 1 and 20 over 100. So that's how we're getting 20%. Or you could just put a 2 here. These first two decimals is what you're going to put over 100. So that's just 100%. 2/3, another way of doing this, you can either put it over 100 if it's easy to multiply that way, or in this case, you can divide 2 by 3. And then you can see that 3 doesn't go into 2, so we add a 0 here if we go with decimal. 3 goes into 26 times, that would be 18. We get 2, we subtract, and then we realize, oh, we get 6 again, and we're going to keep on getting 6. All right. Now, that's 0.66, etc. And remember, I said you could take these first two and just put them over 100. Or another way of thinking about that is you're multiplying by 100. So 66 out of 100, or 66.6%. Same with this one. This guy is, if I'm going to multiply it by 100 to get the percentage, this just moves the decimal over 2 places, which is why it's here, 0.042%. So still a very small amount. 3/5. Now, I'm going to show you an alternative way. You can divide 3 by 5 and you get 0.6. You also could easily here multiply by 20 to see that makes the denominator 100 and makes the numerator 60. And 60 out of 100 is 60%. Because anytime you have a number over 100, that's the percentage. And okay, yeah, sorry, 214, because it's 2 is the whole number. So if I want to do 1 divided by 7, I see that 7 goes into 10 3 times, and that would be 7, and I subtract it, get 3. If we down to 0, I would get 7 goes into 3, 30. How many times? It goes in 4 times. So what's that into right here? 1 here, not 3, another thing. 7 plus 3 is 10. 7 times 1 is 7. Sorry about that. That's 1 time. 7 times 1 is 7. Subtract to get 3. Bring down to 0. So 7 times 4 is 28. And then we get 2. We bring down to 0. 7 times 7 is 14. We get 6. We can keep on going for a while here. So we have 0.147, etc. Now, if I take that 0.147 and I multiply it by 100, I get 14.7%, which is that right here. That's where they get the 214. They're adding it to the 2 times 100. So if it's a decimal, you multiply by 100. If it's a fraction, you can divide and then multiply by 100, or you can make the denominator equal to 100. So now we're going backwards, 5%. So the easiest thing to do here is to divide by 100, or to imagine that this is where the decimal is, and you're going to move it back 2. So that's why it's 0.05. Imagine this is a decimal, move it back 2. 2/3%, you need to divide 2 by 3, and that's where we get 0.00. This isn't supposed to say percent. If I divide 2 by 3, then I get 0.6, okay? And then if I want to make it, let's say a percentage, so now I'm going to move the decimal back 2. So you're going to 1, 2, so it's 0.0006 repeating, just that, not with the percents in. They should have left these percents off because you're going to a decimal. 6.3, again, I'm dividing by 100 or moving this back 2. So 0.063 divided by 100 or moving the decimal back 2. So as we get 2.5. Same idea here, 33.3%. This 33.3 repeating. If I move the decimal back 2, I get 0.333 or 0.3 repeating. So when you're going from percents, if I want to make the percent a decimal, you're going to divide by 100. And the opposite when we're going the other way. 100% of number. Okay, so let's see if we can talk about how to do this. A house that sells for $92,000 requires a 20% down payment. What is the amount of the down payment? We need to find 20% of 92,000. So when you hear that word of means multiply. Okay, so if we change 20% into a decimal, then you're dividing by 100. 20% is the same as 20 over 100, which is the same as 0.2. And then of means multiply. So you multiply these together, that's what you get. Another way of doing this that I always do mentally is 20% is a 10% plus a 10%. And 10% is really easy to find. You just move the decimal over 1. So 10% would be 9,200. So 20% would be 2 of those, which is 18,400. Now, Roger has 45 correct answers on the 80-question test. What percent of his answers are correct? So I've used this a lot in grading, actually. So 45 out of 100 is equal to what out of 100? If we're trying to get 45 out of 80, sorry, is equal to what out of 100? So you're going to cross multiply. Usually I cross multiply and I show it like that. So I'll do 4,500 plus 80, and then you divide by 80. And so we get 56.25. So his answer, his grade would be a 56. 42% of the parents of the school children in Paxton School District are employed at Diploma University. If the number of parents employed is 168, how many parents are in the school district? So 42%, this would be 42 over 100 or 0.42. 42% of the total parents are employed. And it says if that number is 168, then how many parents are in the school district? So you're going to divide by 0.42. This is one way to show the problem. You also could say 42 out of 100 times the parents is equal to 168. And then if you wanted to multiply by the reciprocal, that's the same as dividing. We could do it this way. So let's see how I model it here. So 400, there are 400 parents in the school district. Steve at a sports store in the Humphrey Summit on sale for $476. If the original price was $560, what percent are they discounted? The original price was $560 and the new price is $476. The skis are discounted $84. The discount would have been taken from the original price, so we need to find what percent 84 is of 560. So it's a little tricky, okay? You don't just put 476 over 560. You find the difference here. You find the difference. So first you subtract. You see the discount was $84. And we're going to take that over the original to figure out what the percent was. So if you just divide 84 by 560, you get 0.15. And if you want to multiply by 100 to get the percentage, that is 15%. Fraction equivalence percent, 25% is the same to 4. 80% is half, so 70% is 3/4, 33 1/3 is 1/3, etc. Frequently, we may not know a percent of something, but we know a close percent, so we could estimate. So 50% of 62 is a half 62. 5% of 62 would be 1/2 times 10% of 62. So if we found 10%, that just means over 6.2 and then halving it. 55% of 62 equals 50% of 62 plus 5% of 62. So what they did here is instead of finding 55%, they're like, you know what I'm going to do? I'm going to find 50%, which is basically, well, cutting this guy in half, so that's 30. Then I'm going to find 5%. So 10% is 6.2, so 5% is half that, so that's where I got 3.1. So that means I can add these together to get 55%. That's what they did there. When I went to buy blouse, it was in the price of $26.50, but now it's on sale for 40% off. She has $17 in the wallet. She have enough cash. So it's easier to find 40% of $25 versus $26.5. So 40% of 25 is 4 times 10%. This is my where I extended the 10% trick. So if I do 10% of 25, that's 2.5. And then you multiply it by 4. And then that would be 8, 10. So that'd be $10. That's how much she would be getting off of the 25, which would be about 15. It's 26.5. Since after is kind of greater than 10, Laura will have to pay less than $16.50 for the blouse, so she doesn't. Another way of doing a problem like this is instead of finding the discount and subtracting, you can find how much she's going to pay. So she's going to pay 60%. So I think that's actually easier. So that's like take the 2.5, that would be 10% and multiply by 6. So 12, 15. So she's going to have pay about $15. So I personally think these. Which of the following statements are true, which are false? Leonardo got a 10% raise at the end of his first year in the job and a 10% raise after another year. His total raise was 20% of his original salary. That's not true. Let's make a really easy problem. Figure out why. Let's say he made $100. All right. If he gets a raise of 10%, what's 10% of 100? Well, it's 10. So that would mean he's at 110. Now he's getting 10% of this, not 10% of the original. So now 10% of this would be 11. And so we added that together, we'd be at 121. That's not the same as 20% of the original thing. Johnny and Dina, if 45% the first department store bill, 620, 48% of the second department bill, of 380. And playing, oh, this is not right at all. They're adding the percentage and then taking it off the total. That's not true. You have to find the individual amounts. So you need to multiply 45%. So this would be like 0.45 of 620 plus 0.45 of 380. You can't add the percents together, or not 4.48. You cannot add the percents together and do it off the total cost because they're individually calculated differently in that problem. Bill spent 25% of his salary on food and 40% on housing. He spent 65% of his salary. Yes, that's true. In a town, 65% of the adult population workers is in town. 25% across the border and 15% is unemployed. Everyone in town is exactly one of these categories. Well, do the percentages add up to 100? If I add 65 and 25, that puts me at 90. And if I add 15, wait. The 15, I'm at 105. Okay, this is greater than 100. So that means there must be some people that are overlapped in those groups. It will make sense to get 105%. In Clean City, the fine for various pollutant activities is a certain percent of the fund's monthly income. The fine for smoking is 40%, for driving, polluting car, it's 50%. Littering is 30%. Mr. Swipes committed all 3 polluting crimes in one day and paid a fine of 120%. of his monthly income. So because they're all the percent off the same income, you can add them together. One way to algebraically show this would be, say that I represents his income. To figure out how much you pay for the smoking thing, it'd be 0.40 times I, then it would be 0.50 times I, then it would be 0.30 times I. And since they're all off the same income, I can add all these together. I add 5 and 4, I get 9, 10, 11, 12, so that's 1.2% of his income he would have to pay in fines for that one day. Steep fine. Suppose you borrow $6,000 from the bank at simple interest and pay 5% to pay off 2 years. The $6,000 represents the principal, the 5% is the interest rate, the period of the loan is the amount of time, which is 2 years. This is a simple interest formula, I equals PRT. The formula for the total amount is P plus the interest, so the principal plus the principal plus the rate plus the time. So it's P times parentheses 1 plus rate times time. So Vera opened a savings account that pays simple interest for a rate of 5.25% per year. She deposits $2,000 and makes no other deposits, final interest in the final amount for 90 days. So the interest is that $2,000 times that 5.14% times time. Okay, because remember, this is principal, this is interest, this is time. Now, why do we put it over 365? Because this is in time in years, right? So 90 out of 365 represents how many years there would be. And so that's this. And then, so the amount she's going to need to pay is the original, which is the principal, plus the interest, which is this. Find the annual interest rate of a principal of $10,000 increased to $10,900 and then defeat a 1. The R, the annual interest, we know the R percent of 10,000 is the increase. So what's the amount of increase? You subtract, you get 900. So what percent of 10,000 is equal to 900? That's what this is figuring out. It's like something out of 100 times 10,000 is equal to that 900. That's what formula they're using here. And so these two zeros cancel with those two zeros, so we get x times 100 equals 900, and then we divide by 100. And so you get x equals, or in their case, they wrote r equals. Okay, so that is about percent, decimals, fractions, kind of how they are related in real world problems. This is stuff that you really can use. I know even whenever a kid is like, hey, can I buy this really expensive bat at the store? And then you can say, it's 35% off. How much are we going to be paying for the bat? This is a lot of real world applications. So hopefully you found this useful. And if you have any questions, as always, please just reach out to me.